Strange and unusual talents. That was the bit that jumped out of me from that intro. Nothing better describes me than that. Strange and unusual. Good morning. You all look very sprightly. That's because it's not Monday. Yesterday I did the course on this very topic, and I have to admit everyone was an absolute soldier to be there bright and early and look like they actually were paying attention. It's fantastic. I don't know if they were. A few of them are here. I'm not going to ask you to raise your hands if you were paying attention. But echoing what Sebastian said, when I'm wandering around outside, I should warn you, I am an introvert. However, if I look like I'm slightly lost and nervous, just come and chat to me. Ask me about anything I'm going to talk about now, or anything generally. Okay, so let's get going. We're on the screen, cool. Okay. Cool. That's often enough. That just feels like it's good. I always think I should stop there and say, that was it. That was the moment. Just Yay! We're done.
She said, of course there is. You're still alive, she said. Oh, do I deserve to be? Is that the question? And it's so, who answers, I'm still alive, yeah. I'm still alive, yeah. I'm still alive, yeah. I'm still alive.
You're extremely kind. No, thank you very much. Hang on, I've got a bit of a microphone issue here. I'm trying to wrap it around my ear the wrong way. Okay, so let's get into some content. Thank you for indulging my desire to always play guitar on stage. I actually started doing that to relax myself, which is a crazy idea. And since the talk is about stress, I should talk about the stress of playing guitar on stage. I wouldn't recommend it to anyone. It doesn't relax you whatsoever. Okay, so this is a talk that is, it's usually about a 45-minute talk, and I'm going to try and compress it slightly so that we can get through it all in a time. I need to introduce myself probably to a few people here. You probably haven't seen me before. So who am I? Very, very quickly. First and foremost, I'm a dad. I have to point that out. That's my biggest job in the world. It takes up a huge amount of my time, and I love it. And yes, we are those really annoying people that celebrate Christmas way too early. This was at least roughly a month ago, and we were preparing for Christmas. So yeah, we're unashamedly Christmas fans. The other thing I do is I've written a book, or writing a book. I've written 3 books actually that are published, and this is the 4th that still isn't published. But it's a book on anti-fragile systems, which is related to the talk, in that how do we build systems that can gain from the natural stresses that they are placed under. And I obviously also deliver courses on this subject, but you already know that. But that's not who I am. That's not enough. I am more than this. Everyone has a double life. I have this suspicion anyway. Really, obviously, I think I'm a rock star. I may be wrong. You probably now know I am wrong. But yeah, I do this a lot, and this is another part of me. But that's not everything about me. Very quickly, I'm also a motorcyclist. Now, this is related to our topic for today. This is me recently riding across Europe, and I ride all over the place. But something I want to tell you about briefly is next year, I have got some lovely people have actually asked me to ride from San Francisco to Chicago. Now, that sounds like a reasonable ride. And they've thrown in that I have to do meetups every single time I stop the bike, wherever I am. It's going to be interesting in the middle of the Nevada desert. And just to let you know, this is what the journey actually looks like. It's not as direct as it sounds. You know you've got a big journey when Google Maps cannot allow you to plan it. I never knew there's a maximum number of waypoints that Google Maps will support. And I've hit it several times. But this is the first part of the journey. And this is the second. Now, you can see the obvious musical influence in this part. This is Russ really just wants to follow the road from jazz to country music to rock and roll, right up to the Delta blues. So yeah, to be fair, it's going to be an amazing trip. And I'll be video blogging the whole thing. If you follow me on Twitter, just like I'm doing now, I will live stream every single time I do a talk, wherever I am. Okay, so does that make me absolutely insane? And the answer is probably yes. But it's not the only characteristic I'm known for. I'm also known for chaos, which is related to my insanity a little bit. And the thing about chaos is that it's a terrible term for what I do for a living. Honestly. Number one point I want you to take away from this particular talk and about stress and causing it through chaos is chaos engineering has absolutely nothing to do with causing or creating chaos. We were talking about it earlier. Coming up with names in this industry, I think we should be banned from naming things. Particularly naming things after what they're not. You know, NoSQL, serverless. Whoever named those things, stop it. Name them after what they are, not what they aren't. And chaos engineering is a bit like that. It's not about chaos. It's about the system itself being chaotic and fighting and working with that chaos to make sense of it. And this relates to the point here that I mentioned earlier about production. Production in the talk, in the video, production hates you is the starting point for your mind today. And I mean it really hates you. It knows where you are. It knows when you're on holiday. It knows when it's 9 p.m. on a Friday and you're out having a few drinks. It knows. And it hates you for it. And when you're dealing with production, when you're in a DevOps sort of mindset, I encourage people to think like a motorcyclist rather than thinking like a car driver. Can you raise your hand if you drive a car? Yeah, it's usually a lot of people. In Germany, everyone drives a car. If you do that in London, you get a load of people going, I just go on the tube. Never driven a car in my life. Okay, who is a motorcyclist? Brothers, love it. Okay, so right, so there's a difference, and hopefully you'll realize this, and this might be how you get trained in Germany as well. As a car driver, you're taught out on the road that no one can see you, so you drive defensively. But as a motorcyclist, you're taught a different lesson. You're taught that everyone can see you, and they want you dead. It's not paranoia if it's true. And it's that way that you stay alive a little bit longer. And that's a good attitude to take. And that's how I would like to start the game and encourage you to think of production that way. It is out to get you. Production absolutely hates you. So some people, when they explain production to me, it looks a little bit like this. This is about 5 minutes from my house. This is a beautiful part of the Sussex Downs in England. Now, what you don't see is just to the left is sort of a world-famous suicide spot. So even though you're looking at a beautiful scene here, just to the left, there is the echo of screams. But it looks great, and this is what production is often explained to me as. And when I hear that this is production, this is usually my reaction to it, which is that, yeah, okay, that's what you think production is like, but really, is it? You see, you think it's this, and I'm fairly sure it looks a bit more like that when I go and meet it. And there are usually some extremely talented people trying to keep that fire away from the rest of the organization. So takeaway point number 2 for us. Failure in production is absolutely everywhere. Nothing works. It's a miracle when anything works. Not only is it failure, but there are different types of failure. The hardware hates you. The hardware will fail at the right moment for it, not you. The functions, the stuff you've written, will fail. It will be wrong. The wrong versions will conflict. State transmission's a beautiful collection of failures. That's where you think you've sent some information around, but it's not quite right. And so the system gets out of step. And so interesting things occur. And there's the obvious ones like latency when you're working with these systems. If you're building a microservice-based system or if you're rebranding it as cloud native these days, then latency is something you should be an expert in. You create it all the time. Not for a bad reason, but you need to know it's there. And these are one of my favorites, resource exhaustion. This is where, you've got, I will not ask you to raise your hands if you've written software that has maximized the memory usage on a particular device. That would be unfair of me. But that's what it looks like. Memory exhaustion, CPU exhaustion, these things happen. And there are loads more. And there are fascinating combinations of them too. And we don't need to get theoretical to know these things. We see them all the time. These are the obvious sort of viewpoints on these things happening. I particularly like the one on the bottom left. I really don't, I'm not one of those sort of beaters for Microsoft. I'm not going to beat them up. I just like the phrase used by the journalist, which is this idea that Microsoft doesn't learn. I don't think any of us do particularly well when these conditions happen. And I think we approach the whole problem wrong. We seem to think that these things are the issue rather than an opportunity. It's not just Microsoft at all. It's pretty much all of us. And I love this as a particular tweet. You probably saw it in the video. It's one of my favorites. The cloud never goes down, they said. S3 can't go down. A region of Amazon cannot go down. And then they do. And that's life. In fact, if anyone ever says to you that can't happen, it will. It's called Murphy's Law. Okay, takeaway point number 3 for you. Chaos engineering has a specific job. It is only about availability. We're trying to build confidence that these crazy systems we've constructed are going to be available the way we would like them to be. That's what chaos engineering is about. It's about building confidence. Availability turns out to be the main thing that matters. And we can measure it from the outside in. We can see it from the outside. And it's a property of the whole system. How available is this particular feature in the system is a question you can ask. And you can measure it in a number of different ways. You can do it based on time. These have come straight out the Site Reliability Engineering book. If you haven't read that book, read it. I'm sure you have. Time-based availability. This is the idea that there's some uptime, there's some downtime, and we're going to work a sort of percentage, a ratio for that. And then there's aggregate availability, the other form that's most commonly used, which is number of successful requests, taking away the total number of requests, divided by the total number of requests. I'd like to translate that slide actually a little bit. An unsuccessful request is an angry user. That's another way of looking at it. Make it more human from an availability perspective. Okay, and yeah, you measure it from the outside in, which is really helpful because if we had to measure it across the whole system, it would be really problematic. But it turns out to be tricky enough in and of itself. Getting availability when we've built a massively distributed, cloud-native, microservice-based system is very difficult. There are loads of different factors, transient, temporal factors that affect it. And so it's absolutely impossible to formally prove the availability of your system, to sit there and go, in advance, we know what the availability is going to be. Real life isn't like that. And it is affected by so many different levels. We all understand the infrastructure failures. We can sort of see that happen. We can understand how that might, burn out. But then you can rack it up through all the different layers in your system. I call this the Sociotechnical System. It's a phrase I sort of borrowed from Jessica Kerr. It's everything that surrounds the software that tries to get it to work and generally ends up failing. So platform, whatever you have construed as your platform, whether it's Kubernetes, whether it's Pivotal Cloud Foundry, whether it's Mesos, although Kubernetes is one, but maybe it's Mesos. That is another area where failure can take your stuff out. Availability can be affected by it. Applications, the stuff you write, will of course affect your availability. And then the top one is the one I like the most, because this is where the majority of the availability problems have happened, in the people. S3 was taken down because a command was used. I had a great story over in the UK. A friend of mine runs a company. He turned around and said, I was sitting there one day, and a gentleman next to me turned around and he said, I found a button. I said, what do you mean you found a button? He said, I found a button. And he said, what do you mean? And he said, well, it's a button. If I press this button, everything goes down. Everything. And then before my friend could turn around and say anything, he heard click. And you know what? The button worked. And he found out that he could bring the entire system back in 45 minutes. Now, you could look at that and go, oh my goodness, let's get rid of that button. But I would like you after this talk, after hearing my case for chaos engineering, to think differently. You'll be coming at it going, we should press that button more often. The more we press that button, the better we get at our system and its availability. Different way of looking at it. Okay. So first of all, I want to give a little bit of theory around what production looks like. We tend to assume, or at least we hope, that we're building a system that's in the bottom right quadrant. But the bad news is, unless you're working on Hello World, and if you are, I want to know what company you work for, because I'm desperate to find the Hello World company. What a great company that would be to work for. There'd never been any problems in production at Hello World. That's where we have our best practices. That's where everyone can say, just do this. Forget the rest. Do it. It'll work. But that's not where we are. We tend to think we're in the complicated end of things, simply because the sheer number of moving parts And if you're building a monolith, you're probably in the it's complicated area. And in that area, the best you can have is good practices. That means someone can turn around to you and say, try this, it will probably make it better. Unfortunately, if you're working with anything that remotely resembles microservices, and I don't want to get into a debate over what a microservice is, please let's not go there. Whatever you construe to be a microservice, you're not in complicated anymore. You are over in complex. And that's okay. We aim for that. There's good reasons why we're there. Unfortunately, you probably aren't there all the time. If you're building a cloud-native, microservice-based system using all the automation that we know and love, then you're probably trying to achieve a system that can evolve quickly. That was, hang on, there's a slide of this. That was the point of doing it in the first place. We wanted a system that we could change and adapt. We were trying to come up with an architectural style where the system can evolve as quickly as our ideas about what we need. If you have achieved this aim, which is a good thing, you've got constant change in your system, which means you're constantly shifting into the chaotic. Every time you release something new, one small microservice, at once, hopefully at first, into the chaotic area, you suddenly have, we don't know what's going to happening. And so we need a technique to deal with this. And this is Cynefin. This is just an approach to system description and navigation and making sense of these things. And it recommends that you take an approach that says we act upon this system, we sense what happens, and we respond to it. We can't formally analyze it up front. We have to try stuff and see what happens. This is what chaos engineering is. It's the technique to help us deal with the fact that when we have a constantly changing distributed system, which is what we wanted, how do we make sense of it and build any confidence in availability? So number 4 to take away. These slides always make me slightly hungry. Okay, so this is actually a quote. This approach is potentially as revolutionary as extreme programming. That's probably a little too far, but I quite like it as a poster quote. It is certainly extremely powerful, this approach. And I suspect by this time next year, most of you will be considering it or doing it. Because who wouldn't want confidence in availability of the system? This is the big takeaway. You're building system confidence in these rapidly evolving, often chaotic systems. Point number 5. How do you do chaos engineering? What does it look like when you do it? The first thing you're going to do is increase the observability of your system. This is sort of bar 1 to go into this. I mean, the analogy for this I have is, if you've been to a sort of a theme park recently, then you'll probably go to one of those rides where it says you need to be this high to ride it. Now, I'm a fairly short Englishman, and as I walk towards those rides, I often realize that I'm actually probably not tall enough to ride them. But observability is that bar when it comes to chaos engineering. You cannot play with your system with chaos engineering and improve it unless you can have confidence in observing it. Because you need to have a theory, a hypothesis about what steady state is. What that means is, what does normal look like? In a rapidly changing, evolving, transient conditions and system where everything's trying to die, what does normal look like? You need to be able to observe that. It's actually easier to come up with than you might think. One of the things you can look at, if you're doing automated canary deployments, then you probably already have the beginnings of the stats that you would use to declare something healthy. Therefore, the stats you could use as the baseline for some of your steady state. So there must be a decision point where you say this service, and we can now switch over to the new one. Whatever those pieces of information that you gather to make that decision, that's probably the beginnings of your steady state hypothesis. Now, the way that chaos engineering is normally presented is that they don't normally go to this topic next. But I like to go here next because it stops people worrying so much. So once you've got a steady state hypothesis, the next thing you do is you talk about blast radius. You say, how much of the system do we need to affect in order to learn something? How far do we need to go? And you start really small. The very last thing I want to hear from anyone here after today is, Russ said I should run Chaos Monkey in production, and I did, and it broke everything. Blast radius, people. Don't run any of this against your whole system as your first decision. It won't endear you to anyone, and management won't be your friend. So limit the blast radius. Figure out how much you need to affect to learn something. And then what you do is you try and vary the events. You try to vary the conditions. And the important words here are real world. It's not fair to go to a system and say, well, we destroyed everything and nothing worked. We've learnt nothing other than what we already knew. And everyone's sitting there going, that never happens. So you have to come up with conditions that are maybe a little extreme, but they are possible. Otherwise, people will ignore what you're doing. And then and this one's controversial, you have to run them in production. You don't have to, but it's where you're going to get the best learning. The trick with chaos engineering is you're trying to learn how to build confidence and availability. If you build confidence and availability in staging, guess what? All you've done is build confidence in staging. You want to build confidence in production, probably. So that's why we say you kind of have to run these things there. And you should be automating your experiments as much as possible, because we run them all the time. It's no good you running one of these chaos experiments today and going, hey, we got availability, it seemed to survive, a steady state was retained, we're all good. And then tomorrow it all collapses and you go, well, why did we run that experiment? That was pointless. So what you need to do instead is run these things all the time. Point number 6 for you. Chaos engineering affects all of those levels. Most people fixate on the low level. We'll do chaos at the infrastructure level. That's because of things like Chaos Monkey. But what you want to do is use chaos at all of those levels. We use different techniques for different levels. At the top level, we use things like game days, which are a fantastic technique. If you're not doing game days, do them. They are fun. You get everyone in the room, you destroy a chunk of staging, and you go, fix it. And then you find out just how fragile the whole system is when everyone is panicking and cannot find the playbook and cannot find the one person who knows how to do that thing with the database. But you can do most of the other things automatically across the system. Point number 7. Right, there are some rules of Chaos Club, in my experience. The first rule is about learning. It's not about harming the system. You're not just trying to hurt something. You do often break things, but you're doing it to learn something new. If you're not learning something, don't do the experiment. When anyone comes up to me and says, we did Chaos Monkey, and well, we knew it would destroy our system, and it did. I sit there and go, well, why did you do it? Only do these experiments if you don't know, or if you suspect it might not affect the steady state. And chaos should never be a surprise. This is a big one. Don't turn around to anyone and go, yeah, I ran Chaos Monkey against your production system. Surprise. No one will appreciate that. It's actually an extremely collaborative process. You will sit there and talk to the teams and go, what do you want to learn about availability on your system? What do you want to try to see if it survives? Yeah, and number 3 is really a reiteration of that. If you already know the consequences of your experiment, don't do the experiment. Okay, if you know your system cannot handle a particular service being destroyed or a database connection being removed, then don't do it. You already know there's a problem. Improve the system to the point where you believe it will survive. Then run the experiment and find out just how well it survives. Some frequently asked questions. Isn't this just testing? Aren't we just doing chaos testing? Sometimes it's called chaos testing. The way I think about this is it's more about open-ended questions where we don't know what we don't know, as opposed to verifying and validating something we do know. Testing tends to be, I know this is the way it works, and yes, it works that way. Whereas in chaos engineering, we often don't really know how the system's going to handle this. And so we try something and we discover how it deals with it. So it tends to be a hypothesis that we work with, not trying to verify something, and we're trying to discover about the system. So it is a small point. It's a bit like exploratory testing in some respects. And it's about more than just single loop learning. We're not just trying to go, yes, it works the way we think it does. We're trying to challenge our assumptions about the system. We're trying to break our own beliefs in how the system will work under certain conditions. Okay, so how does it look in a company? Well, it looks a little bit like something you're probably already familiar with. You often have a security group alongside everybody, and then you'll sometimes eventually have a chaos group alongside everybody too. At first, you don't have that. At first, you have people that just have a general interest, a community of interest, and then they gradually become a separate group. And what that group will do is you'll have game days that you facilitate, and you will automate experiments across the whole system. Okay, so some tips if you're going to adopt chaos. Number one, don't be afraid not to say chaos engineering. I mean this for the managers, or the senior stakeholders, or the directors. I never use the term chaos engineering at the board level in a bank. Do you know, do you want to do some chaos? No. Really, no. We did that. 2008 was great. No, we don't do that again. So, yeah, don't be afraid to drop term. I tend to use limited scope, continuous disaster recovery. It works. It works every time. We're going to learn something new about how your system handles a disaster. Oh, I like that idea. As a bank, fantastic. It's a limited scope. Great. That means the whole thing doesn't crumble. Good too. And we're going to continuously do it. Fine. Don't care. We're going to do chaos engineering. What? And this helps you to answer the question, we can't possibly do this here. Yes, you can. Just call it limited scope, continuous disaster recovery. In fact, you can often answer the question by going, do you do disaster recovery? Yes. Cool, we're just going to do that more often in a small way. And one of the big things to talk about very early is blast radius, that limited scope thing. Start the conversations there. It puts everyone's mind at rest. If you ever say chaos monkey or anything similar to people, the very first thing they'll turn around and think of is the whole system dying. So don't start with that. Say, what's the smallest scope thing that we could try? What's the smallest thing we could destroy? And eventually you'll grow a capability in the organization, which starts off as a community of practice. Then you'll do these game days collectively, which is the most fun thing to do in the world. And then you'll end up with a community of interest and eventually a whole group that probably is doing some of this. Good news is it's not a very big group of people. A chaos engineering actual group is, for a massive organization, is probably less than 10 people. In my experience, less than 5. There are some characteristics that they need to have in that group. I should warn you of that. If you're thinking of becoming chaos engineers, there's one personality trait you must have. Empathy. If you're in any way inclined towards sadism, then chaos engineering is not for you. It's a huge opportunity to upset an awful lot of people. So you need empathy with them, you need to work with them all the time. So some enterprise challenges with chaos. You'll do the game days, like I say. They are great for building awareness of what we don't know. They'll make people aware of the weakness. Game days are a great way of answering things like, if you've got developers and you want them to do better logging, do a game day, because then they consume their own logging. and they'll realize how terrible it is. When things go wrong, they'll be looking at their logs going, can't see anything. It's like, yeah, your logs are rubbish. Let's work on that. You get immediate improvement just through game days. You're going to need to collaborate when you're planning. When you're planning your chaos experiments, you should be planning and scheduling them and making them aware to everyone. Like I say, chaos is not a surprise. You're going to get approval. Please get approval. We're going to run chaos against your system, and we did it yesterday. Is that good? Get approval from as many people as you can that this is something that you want to learn. And you need to make them aware when you're running chaos. You'll need a dashboard that says, we're doing chaos right now in these parts of our world. Because people are going to panic when they start to see things die. And it would be helpful if they could go somewhere and go, oh, it's you. And keep sharing the results. I have actually worked with chaos engineering groups where they sit there and go, we've got all the answers. Don't want to tell anyone, though. And I've never quite understood it. You have to share it out there, and there'll be insights that you get. The beautiful thing is the insights are usually all those things that you find it hard to make people care about. Those are the things that chaos engineering makes really obvious and needed. So circuit breakers, structured logs, decent tracing through the system, decent service discovery, all of those non-functional things are motivated by chaos engineering. And they make these things unignorable. And those are the insights we talk about here. And you've probably got pieces already that are already ready to do chaos engineering. So you probably have to integrate with what's already there too. And finally, you might need to run chaos locally. So I'm going to briefly talk about what I've been working on that you could use today. There's a free and open source toolkit out there that does chaos. Go and grab it, have a play with it. I'm always improving the docs. There is a Slack team that you can go and join. I think it's join.chaostoolkit.org. And you can come and chat to me immediately about your experiences with it, and I can try and help you improve that experience. The aim of it is to come up with a consistent API to chaos so that we can have a description of an experiment, and then we can choose what systems and tools we run it with under the hood. So that's the game we're doing there. And it's also supposed to be the easiest way to get started. So this is a great starting point if you want to go and play. Then there's also some tooling that I've developed. If you're interested at all, just come and chat to me afterwards. So the Chaos Toolkit's great for getting started with chaos, but some of the other enterprise challenges are still there. So collaborative planning is still a challenge, sharing what's going on, being able to schedule what things do, getting approval, please get approval, and making everyone aware of the execution of your experiments, and finally producing results and insights. So we've got this little tool that we do this at the moment with a couple of customers. If you're interested in doing it in your company, this might be of interest. But get started with the Chaos Toolkit, because that's the open source and free one. And it will get you into the mindset. Okay, so who's doing chaos? Just to finish, the last thing I promise, and I'll leave the stage. Who's doing this? It's getting to a point now where the question is more who's not doing it yet. Okay, I want you to ignore the big names up here. So everyone sees Netflix and goes, well, we're not them, so they can do it, but we don't have to. The interesting thing is the less cool names, I suppose. Not to say that they're uncool, but they're less cool. Things like Morgan Stanley are doing it. There are a bunch of banks in London doing this. They don't call it chaos engineering. Limited scope, disaster recovery, continuously. But they're doing it. I know they're doing it because I'm helping them. But there are a whole bunch of companies out there that are actually coming out of the proverbial closet and saying, we do this too. And here's the takeaway. If you're running microservices in production, if you've got a complex towards chaotic, constantly evolving, cloud-native distributed system, a lot of us have now, then you need to do chaos engineering. It's one of the few best practices in the complex and chaotic area. There's two as far as I'm concerned: observability and chaos engineering. Everything else is context sensitive and unique, probably to your problem space. So do it. And the great news is the book is free. I have so much respect for the individuals that made the decision to write this book, put the effort into it, and make it free to everyone. So you can go and grab this right now, and you can get started doing chaos engineering with the Chaos Toolkit and this book in your hand, and you'll be accelerated straight away. And it's free. It's free. Come on. Okay, that's all I have for you today. Hopefully I've whetted your appetite for chaos engineering. If you've got further questions, and I suspect you have, then come and have a chat with me either when we're finished here, or if you see me wandering the aisles out there, just come and have a chat with me. And I'd love to talk to you about the different experiences I've had with chaos engineering with lots of different companies. I hope it's been of use. I hope it sets the stage a bit for your conference. Have a fantastic time over the next few days. And I hope the conversation continues. Thank you very much.